Hello, welcome friends. Again we are meeting with the next topic in surveying, first unit. We have already completed the chain surveying. In the chain surveying we can measure the linear measurement, and we have seen about what are the errors may occur, how we can correct it, how we can get the true length. But the chain surveying alone can't give the direction at which the line was measured and how we have to orient. These things cannot be given in the chain surveying. So to determine the direction and to maintain the surveying in a proper manner, the next development is the compass surveying. That was the one of the outcome. First outcome, calculate the areas and include the angles based on the concept of chain, compass and plane table. We have seen the chain. Next we are moving to the compass surveying, right? Based on that outcome, how we can calculate the areas by compass surveying. That is the fourth yellow. It can be split into the following specific outcomes. From that we can list the types of compass with their least count and their accessories, explain the error in compass surveying, various methods of correction to be applied in compass surveying, importance of those methods, then with respect to those methods how we can calculate the area by include angle method and the bearing correction. In this video we tried to complete the first SO1 and SO2 alone, right? So the total content of the this PPT will be introduction about the compass surveying, prismatic compass, its construction and working, surveyor compass and its working, their difference. There are some systems of bearing and types of bearing that we are going to see. Then what are the different types of errors, right? So these are the things we are going to see in this content. So compass surveying. In compass survey, chain or tape is used for linear measurement and compass is used for fixing the direction. So here we have understood that chain become one of the accessory for the compass surveying, right? So in compass, freely suspended magnetic needle directs to north and south, and the bearing of line is obtained by line of sight. So here the new term arises, bearing. This bearing have different meaning. In mechanical engineering, the bearing means it is a small ball, steel ball used in the chains, that bearing. But in civil engineering it has two different meaning. In surveying it is based on the direction, how the line get deviated. Another point, in the point of soil mechanics, the bearing capacity of the soil, how much it can bear. So there are different meaning. Now we are going to try to adopt that, how the line is get deflected or deviated from a particular direction, right? So that direction, if we connect with the north and south, it is called the bearing. Otherwise it is simpler angle, right? So principle of surveying, the principle of compass surveying is traversing. So the word traversing here means, already we have know what is traveling. Traveling is from one point to another point, but here the word traversing means carrying the proper instrument in our travel such that we can measure the required things. So that is called the traversing. So here we are going to carry the compass and its accessories, which involves a series of connected lines, right? So that is the main principle of surveying. So the traversing may be of two different types. One is closed traverse and another is a open traverse. Open traverse means it is start from one point and it end at some other point. It won't get closed, right? So that is the open traverse. If the starting point and the end point are same, get close, then it is a closed traverse. In that only we can determine the area of that particular area, particular plot or whatever it is, right? So if it is open traverse we can't, but we can get the direction at which we have traveled, right? So these are the things we have to consider. So this becomes the principle of compass surveying. So here we deals with the magnetic bearings of the lines are measured by prismatic compass, and the distances of the line, that is A, B, B, C, C, D, whatever, are measured by chain or tape. Such survey does not require the formation of a network of triangle. It obviously makes a proper shape such that we can create very easily to determine the area of the particular piece of land or the large area, right? So this figure shows that it is a closed traverse. So here we have to determine these angles, but the compass won't give this angle directly, right? So this traverse is called, start from A, it keep on moving and it ends again at A. So this traverse is called the closed traverse. If it ends in the E itself, or it moves on in different direction, then it is an open traverse. If it get closed only, we can determine the area. This area look like a pentagon. It may be of any quadrilateral or any polygon. So such that with some mathematical relation we can get the area of so the length of this line can be measured with respect to chain, and the angle can be indirectly calculated with the help of compass. That we are going to see one by one. Here the traversing means when large area are involved, compass surveying is used. Traversing is the type of survey in which a number of connecting survey lines form the framework, and the direction and length of the survey lines are measured with the help of angle measuring instrument. Here the angle measuring instrument is compass and a tape respectively. When the lines form a circuit which ends at the starting point, it is a closed traverse. If it not ends, it ends elsewhere, it is the open traverse. To understand the compass surveying, we should know about the earth magnetic field. Somewhere else in geography or in your school education, you may come across the word meridian or the true meridian or even the magnetic meridian. Here it's a recap of it. If this is the globe or our earth, it has its own axis, central axis. With respect to that only the earth is revolving, right? So we are saying that it is a polar axis, north and south. So here similarly the north pole, and here another thing is there is a red line here shown. It is the magnetic meridian. Here this is the true meridian, it is the magnetic meridian. What is the difference from the thing? The line or plane passing through geographical north pole and the geographic south pole, it is the true meridian. When the magnetic needle is suspended freely and balanced properly, unaffected by the magnetic substance, it indicates a direction. That particular direction is called the magnetic meridian. The angle between the magnetic meridian and a line is known as the magnetic bearing. It is shown here in the red marking, right? And the line is the magnet bearing or simple bearing of a line. So always the bearing of a line refers to the with respect to the magnetic bearing, not from the true meridian. Why so? The true meridian can be obtained with so precise equipment only. With the compass we are going to deal hereafter. These things are we can hold, or we can hold in the tripod in the ground. It has a needle, it can freely move, but it shows the magnetic meridian only. it may be this way or it may be this way also in the dotted blue line. So with respect to that meridian, if you are measuring the deflection or the deviation of any particular line, that is called the bearing of the line. Then the difference between the magnetic bearing and the true bearing, it is called the declination, right? So the line from the true meridian, it is the true bearing. The line from the magnetic bearing, it is the magnetic meridian, it is the magnetic bearing, right? So the difference between the true bearing and the magnetic bearing, the small deviation, it is called the declination. So it will happen because of the earth is rotating in the free space. It has its own magnetic circles, right? So based on that, it varies from place to place. The pull varies. So predominantly in every point in the earth, it has its own deflection. So predominantly we use the magnetic meridian only, right? So the magnetic declination, the term, the horizontal angle between the magnetic meridian and the true meridian is known as the magnetic declination. The dip of the magnetic needle. Any compass, there may be a small dip or upper dip or the lower dip. If the needle is perfectly balanced before magnetization, it does not remain in the balanced position after it is magnetized. Some magnetic particles, if it makes a pull, it won't settle in the proper position, right? This is due to the magnetic influence of the earth. The needle is found to be inclined towards the pole. This inclination of the needle with the horizontal is known as the dip of the magnetic needle. It may also result in the variation in the bearing, right? Now you try to remember these two pictures, right? From this picture we will move on to this picture. If this is the true north and it is the magnetic north, the difference between these two, it is called the magnetic declination. In the previous slide we saw the definition for this magnetic declination. So if there is a line AB, from the true north, if the bearing is exactly measured, it is called true bearing, and if it is measured from the magnetic north, it is called the magnetic bearing. But here the magnetic north is deviated towards the east, right? So there is a deviation, the declination is towards the east, right? So the magnetic bearing and the true bearing, we have to do the correction. See this formula, you try to remember. True bearing, it is the magnetic bearing plus or minus declination. So if I want to get the true bearing, we are able to obtain only the magnetic bearing. There is a deviation, this declination, since it is towards the east, this portion has to be added, right? So plus means use the positive sign when the declination is towards the east. If the magnetic north is away from the true north towards the west, it is negative sign, right? Here the picture shows the magnetic north is towards the west. So it is a true bearing. The magnetic bearing is greater than the true bearing. So here again it is also called the magnetic declination, but this declination has to be subtracted to obtain the true bearing, right? So it is, when you need to calculate the true bearing, magnetic bearing plus or minus declination, it depends upon the position of the magnetic north with respect to the east or west, right? If it is towards the east, you have to add. If it is towards the west, you have to minus. So this can be obtained rightly. If we require the magnetic bearing, the formula can be changed, the true bearing plus or minus declination. Here it is changes towards the west becomes positive, towards the east become negative. Any one you try to remember, either you remember the formula for the true bearing or you remember the formula for the magnetic bearing, and one conversion, right? Now comes the types of compass. In that first one is prismatic compass. In this instrument, the needle remains in the fixed. Here you are able to see a round circle which is holded in the center. This is called the needle. It is in a fixed position, while the two upper graduated circle together with a line of sight. Here it is a vein, and here it is a small arrangement. Through this only we are able to see, rotate about the vertical axis. This can be rotated with respect to vertical, but the needle remain fixed, right? So the entire outer portion can be rotated very easily, but the needle will be fixed. So where the needle exactly frees, it shows the direction of north and south, right? This is the cross section of the prismatic compass. You hold on this slide or this position in the video. You try to remember all the parts here shown in the figure, right? This may we discuss later, right? But you try to, the theory portion they may ask, explain the parts of the prismatic compass with neat sketch, and explain in detail means you have to draw this diagram and you have to explain each and every part. This can be obtained in any book, right? So you try to have a own study in the Google, right? Here the compass was shown in different view. It is a top view. It is in through the side view of the compass to show how the vein will be. Here how the prism and the vein look. This triangular portion in which the prism was attached, if you see through the eye through the prism, it deflects towards the bottom, from which you can obtain the reading. But the side vein raised from here to here, there will be a thread. You can see here there will be a small thread. If the groove and the thread and the object, that is a ranging rod, whatever it is, if you are holding, if it is a straight line and the north will be somewhere else, the angle or the bearing with respect to the north of the particular line can be seen through this prism. Through the prism you are seeing, you can see directly the right measurement, but if you are seeing directly on the above, the readings here shown will be inverted. Through this prism only you are able to read the reading in a right way, but here it is marked in the reverse order or the inverted order. If you see 2 means it's look like 5, so it will be inverted. Through the prism only you can see very clearly, rightly. Next comes to the surveyor compass. Here also 2 veins will be there. For leveling there will be a bubble tube. Here there is a needle, small needle only. Here the frame is fixed, the needle can be floated. Here the readings can be directly measured by seeing the graduated circles, but it is different in the prismatic compass. The surveyor compass consists of a long, thin pointed needle of magnetized steel with a small conical shaped bearing of again material at the center. The bearing works on the pointed pivoted arch seal carried at the center of the low cylindrical metal box. It is of 140 mm diameter. Attached to the opposite end of this box are two side vanes with two slow motion screws and the clamps which able to definite the line of sight to be defined or laid out. The instrument can either be screwed on to a tripod or it can be held in the hand itself. Here, compared to the prismatic compass, the readings will be of 0 to 90, again from 0 to 90, from 0 to 90, 0 to 90. So it is of 4 quadrant. So the reading obtained from the surveyor compass is of reduced bearing or the quadrantal bearing. But from the prismatic compass it is with respect to the north only, so you can obtain the whole circle bearing. What is this bearing we will see later. Right, 0 to 90 degree with north and south direction identified as 0 point, and east and west direction are labeled as 90 degree. The lower horizontal circle can read to 3 minutes directly to the vernier. The disc of glass fitting on the top of the metal case protects the needle and graduated circles. So now the difference between those things, the graduated ring is attached to the magnetic needle. Here the graduated ring and the needle are free to move. Here the graduation are marked 0 and 360 degree in clockwise direction. Here graduation are marked 0 to 90 degree in each quadrant. 0 is marked at the south and 180 degree at the north, 90 degree at the west and 270 degree is marked at the east. Here the graduation are marked 0 to 90 degree in each quadrant. In the compass, east and west is interchanged. It measures in the whole circle bearing. It measured in the quadrantal bearing or the reduced bearing. It may look vague. We will see one by one, then you will get a clear understanding while doing the problem or applying the concept. So while using these compass, and if you are try to observe the bearing, the compass centered over a particular station, say A, of the line AB and is leveled. Having turned vertically the prism and sighting vane, raise or lower the prism until the graduation on the rings are clear and look through the prism. The turn the compass box. These procedure based on the prismatic compass, how the readings can be marked, how the readings can be measured, how the sight to the particular point can be made. This procedure is explained with respect to the prismatic compass, right? So the two terms we have discussed previously, that is whole circle bearing and the quadrantal bearing. What it is means, in this system the bearing of a line measured with the magnetic north in clockwise direction. Here the north alone the reference. From the north all the graduation will be 0 to 360 degree. But in the quadrantal system, in both the north and the south are the reference. From the north to east one quadrant, from south to east is another quadrant, from south to west is another quadrant, from north to west it's another quadrant, right? So 0 will be marked in the north and south in quadrantal system, 90 will be marked in east and west, but here 0 and 360 were marked in the north only, remaining goes on in the clockwise direction. But while doing the traversing from one point to another, if you measure the bearing from A to B, that bearing is called forebearing. When you shift the instrument at point B and look back the A, that bearing is called the back bearing. It is vice versa, from A to B, B to A. So from it may be the clockwise direction it look like this. It is an anti-clockwise direction, the back bearing and forward bearing get changed, right? So therefore the BB, back bearing of a line, differs from forward bearing by exactly 180 degree. If the compass is with a free error, it should be the forward bearing minus back bearing, or back bearing minus forward bearing must be 180 degree. If there is a variation, it is because of any local attraction or the magnetic particles available in the field, or it may be of our mishandling of the instrument also. That has to be properly checked. The maximum the deviation may be allowed, it is of maximum is 1 degree 30 minutes, but it should be avoided, right? So now how comes the errors in compass? Instrumental error, due to the usage of compass for a long time, the needle deviation and the magnetic attraction may be different, so it may cause by the instrumental error. Personal error by the handling person, due to the next, the third one is the due to the natural cause, right? You will see one by one. Instrumental error, the needle not being perfectly straight, it may be get bended, pivot being bent, sluggish needle, blunt pivot point, improper balance weight, plane of sight not being vertical, line of sight not passing through the center of. These are the errors may because of the instrument made wrongly, or the instrument may be too old. So these are the instrumental errors. Personal error, inaccurate leveling of the compass, inaccurate centering may lead to the bearing deviation, inaccurate bisection of signal, not seeing the proper object, carelessness in reading and recording. If we look on reading and we write some other thing, these are the personal errors. And the last one is the natural error, variation in declination, that is the true north and the magnetic dot, that declination may, this is out of our control, it is because of natural thing. Local attraction due to the proximity of the local attraction force, magnetic changes in the atmosphere due to the clouds and storm, irregular variation due to the magnetic storm. This cannot be controlled by us, it is because of the nature alone, right? So these are the things you have to remember in the theory portion of the compass. We will see one by the thing in the next video also. Thank you.